Hello, class 12th physics, RayOptics, important questions, part 2. Draw a ray diagram of reflecting type telescope. State two advantages of this telescope over refracting telescope. So this reflecting telescope is also called Cassegrain telescope. So only diagram is required, so we'll draw it. And of course, you can draw by practicing it many times, and you can directly draw it without using any geometrical instrument as I am doing. So you can save your time also. So there are two parallel rays from a distant source. It will reflect back onto this mirror, and then it will reach that eyepiece. And here we can adjust this eyepiece here. Generally, an eyepiece has these two lenses, uh, or you can mark a single lens here. So this is a typical eyepiece, or in fact you can just put a convex lens here, and of course this is a convex, and this is also convex, plano-convex lens. So uh, that's all. And two advantages of this telescope. All right, I haven't written what is it. It is objective mirror. This is eyepiece, and this is secondary mirror. And okay, it's two advantages. First, no chromatic aberration. Chromatic aberration means a colorful appearance of edges, like prism effect in the lens. But it is a mirror, so it uses objective mirror, so this effect, aberration effect, minimize. All right, second advantage is less bulky. And third, actually it is a part of this second point, requires less mechanical support. And four, larger objective can be made. So according to, we can increase the size of objective mirror, whereas in lens it is not possible. Okay, draw a ray diagram of an astronomical telescope in normal adjustment. Normal adjustment means when final image formed at infinity. So first, okay, draw a dotted line here. It will form, later on we'll convert it into lens. So this is the objective lens, and because it is used to observe far off objects, so only parallel rays will reach it. The rays which are parallel to each other will reach this lens, and from very distant source. So it is not an imaginary object, but it is a distant object. So at an angle alpha is this. And now follow some steps. First ray, it will pass through the optical center. It will pass without deviation, but it will bend. And see, let us suppose here you want to draw its image, then bend this line till it reach this point. So, and you can see I'm not using any scale or anything else. And all right, my lines are also not straight enough, but still it is accepted here. In the exam it will be accepted. So if object is at infinity, image will be formed at focus. This is the image a dash b dash, and the b dash is the very point what is which is the focus of this objective lens. So this is also f of o, fo it is. And now we have another lens, that is eye lens or eyepiece. But if final image formed at infinity, then this lens will also have focus on the same point. So fe is also at this point. For more detail, I have a video on it. Now we can convert it into lens form. And now use two other rays, one parallel. Now these are two other rays, so I'm marking them with a double arrow. Now don't proceed it, and this one, it will go without deviation, it is eyepiece. So now it will become parallel. When it will become parallel, then image will be formed at infinity. So this is alpha, so this is alpha, and this is beta, and that's all. mm, FO, and this is FE. So actually it's the image formed by this will be at focus because object is at infinity, and here we will adjust it. We can adjust this lens till its focus coincides with um, this point where it is producing image. So okay, so two drawbacks of this type of telescope. One, just opposite to that. So no chromatic vibration. So here chromatic aberration. Less bulky, bulky. Require less mechanical support, require more mechanical support. Larger objective can be made. Uh, Larger objective lens is required, but cannot be formed, can not be manufactured beyond a certain limit. Certain limit. Draw ray diagram of compound microscope. Write expression for its angular magnification. So compound microscope, they haven't given the condition, so we will consider when final image formed at D. That is a common condition for microscope, compound microscope. So here this will be the objective mirror. So here its focus FO, here its point O, and object is placed close to FO. So here we go. First ray don't produce it further, but we can do this. Okay, now here image will be formed. AB is the object, A dash B dash is the image formed, and another ray. So remember one thing, uh, let the ray pass the point, and then afterward name it as FO. So put this FO dash, FO prime instead. And now take two more rays to fall on that eye lens. So here we have eye lens, and okay, don't produce it further, but what you can do this. It will pass without deviation, E. And now all right, so now final image will form at D, which we have supposed. So let us suppose somewhere here final image is final image formed. So produce it backward somewhere here, and in the same way produce a line from here, reach here, and produce it in forward direction also. That's all. So this is now A double dash B double dash, and you have to shift this object till this point. Now this is alpha, and this is beta. H of object, H of object, H of image. And what else? UO, this is VO, this is UE, and this is VE, which is equal to minus D. That's all. Oh, most importantly, convert these dotted line into lens. Why I do this at the end? Because sometimes what happens, student often do this thing. They already make a lens, and most of the time on other side eyepiece, they draw eyepiece of same size generally, or in order to make it big, they often do a mistake, like they make it like this. It must be coaxially on the same axis. So be careful, follow my instructions. and its angular magnification m equal to VO upon UO 1 plus D upon FE. They have just asked to write, so we don't need to derive this. Okay, so here two monochromatic rays, 1 and 2, incident normally as shown. Refractive indices of glass prism for two rays 1 and 2 are respectively 1.35, 1.45. So be bit tricky. See, here it is given that refractive indices for glass prism for two different rays. Often we have seen that refractive index of glass is so and so, but here it is written that for two different colors it is different. So it happens, actually it happens, because refractive index is C by V. C is also given by nu lambda, V nu lambda in medium. So refractive index ultimately depends upon wavelength in that medium. I generally write it like this. uh, okay, so now what it means, it depends upon wavelength also. So for different wavelength, refractive index is different. All right, so this is the one thing. Next thing is, okay, step by step, we'll draw this diagram for one at suppose this point is P. Angle of incidence at P is 0, so angle of refraction at P is also 0, so it will go straight. And for 2 at Q, IQ is 0 and RQ is also 0. Now what we will do, we will draw a normal, and now PQRS for 1 at S. This is how you can express your answer without writing too much description. This is how you can step by step, wherever you are taking that ray, and at every interface you can put some symbol, some point, and you can define its position, its angle and all at that point. So for 1 at S, IS equal to, so it is very clear. Okay, I, I made a, not mistake, but I didn't write. Okay, so understandably this is 45 degree, this 45 degree, so this angle will also be 45 degree. We need not to explain it mathematically, it is understood. This is 45, this is 90, this is 45, so this is 45. So IS is 45 degree. Now the thing is whether this angle is greater than critical angle or less than critical angle or equal to critical angle, we don't know. So here discussion goes somewhere else. We have to find critical angle for ray 1. So sine IC for ray 1 is equal to 1 upon refractive index. For 1, I use this eta symbol for refractive index. Okay, so 1 upon eta 1, that is 1.35. All right, side by side, if I write sine 45, then sine 45 will be 1 upon root 2, that is 1 upon 1.41. So we have to compare this thing with this value. So if I put, see what I am doing, it would look like I'm doing some illogical thing, but this is how these questions should be treated. Now if we compare both of these fractions, see its denominator and its denominator, the denominator which is greater, for equal numerator, the denominator which is greater is smaller. Like if I compare 1 by 2 and 1 by 4, numerators are equal, denominators are different. So the denominator which is bigger, that fraction will be lesser. So here this is greater than 1.41, and this is the value of sine 45. I mean, this is inequality of this, but rest of the part is in inequality. So it means, and which is sine IS. So here, if I would write it in front, angle of incident at S is less than critical angle for 1. I hope you people are getting it. Sin IC, just remove all of this. Sin IC is greater than sin IS. How uh, I obtained this? Okay, I just use that expression for critical angle. Sin IC is 1 upon eta equal to, I have put that value. And now what I did, I just, because I know angle of incidence is 45 degree. So I have done it just in a fluke. I took sin 45, put its value, and compared it with this. And I found that this value is greater than this value. So this value is of sin IC1 and this value is of sin 45, which is sin IS. So from here we can conclude, see, this arrowhead is toward sin IS term. It means, see, if I put it that side, this is that side, then arrowhead will be toward IS. So it means angle of incidence is less than critical angle. So no total internal reflection takes place. No TIR. That is, ray 1 will undergo ordinary refraction. Okay, now come to second part. Okay, so okay, now what we will do, we will just draw an approximate emergent ray. So we can calculate that, but it is not the part of this problem. Denser to rarer, it will bend away from the normal. That's all. Now, okay. So for 2 at um, oh, I'm sorry, students. It was R actually. So I'm writing it S. There was a confusion, and I'm writing it R. Okay, I'm writing it as R. So, all right. So these are the mistake you people also do, but be very very watchful. So for 2 second ray at R. So at R, once again, IR is equal to 45 degree. Same process. Sin IC2 is equal to C2 is equal to 1 upon eta 2, that is 1 upon 1.45, and just randomly put 1 upon 1.41. This time this is bigger, means this is greater. Denominator is bigger, so overall fraction is greater. This fraction is greater, which is equal to sin 45, which is equal to sin IR. This angle is I for R position. This implies that IC2 is less than IR, or what we can imply from here, IR is greater than IC2. So incident angle is greater than critical angle. So TIR takes place. And if TIR takes place, so it will 45 make 45 degree here, then it will fall PQR ST at point T. So for 2, oh, I felt that it is still in the video. Okay, now it is in the video. So it was IC, this IC2 is less than IR, and then IR is greater than IC2, so TIR takes place. For 2 at T, IT is 0, so RT is 0, and ray will emerge out. Ray will emerge out from T normally. So here a ray PQ is incident normally on a face AB of equilateral prism of refractive angle 60 degree, understandably it is 60 degree, made of material of refractive index 2 by root 3 as shown in figure. Trace the path of ray as it passes through the prism. Also calculate angle of emergence, angle of deviation. I don't know, but I think um in this question, when it came in the board, diagram was given like this. It was appearing as it, and they haven't given this dotted line, but they have made it in such a way, such badly they have drawn it, so that it was appearing like it is going to hit this vertex. So students were confused about this question. So I haven't drawn it that way, because then this question makes no sense. So if same question and same diagram comes in your exam, so shift it little bit upper side, as I did. So now once again we'll follow the same pattern as we did earlier. At q, iq equal to 0, so rq will also be 0. It will pass straight, and here I am marking r point. At r, ir equal to, let's see. Okay, so this is 60 degree, this is 30 degree, this is again 60 degree. All right, so that's all, 60 degree. And as we did in previous question, in the same way we will do it here also. Sine IC is equal to 1 upon eta, which is 1 upon 2 by root 3, which is root 3 by 2, and which is the value of sine 60 degree. It means that IC is also 60 degree. So here IR is equal to IC, means this is the condition. This is the condition for critical angle. It has incident at incident angle. So when angle of incidence is equal to critical angle, then angle of refraction is 90 degree. What they have asked, angle of emergence, which is equal to angle of emergence. And also they have asked for angle of deviation. So now it will graze along the incident surface. It will graze. This term is called graze. Graze along the surface. What else? Angle of deviation. Angle of deviation means angle between incident and emergent ray. So so this angle vertically opposite this angle means 30 degree. So angle of deviation is 30 degrees. Straight away you can. For a ray traveling from denser medium eta 1 to rarer medium eta 2, prove that eta 2 by eta 1 equal to sine IC. So this is the case for critical angle. Remember this thing. Generally we use a denser medium as we show denser medium with the symbol eta 2 and rarer medium with symbol eta 1. So this time the confusion will be there, but doesn't matter. So let us suppose this is rarer medium as we used to do, and this is denser medium. Rarer medium with refractive index eta 2 and denser medium with refractive index eta 1. So they are talking about critical angle. So at critical angle, so if I equal to IC, if angle of incidence is equal to critical angle, then angle of refraction becomes 90 degree. So according to definition of critical angle, if I equal to IC, then R equal to 90 degree. So by Snell's law, and see Snell's law, you can use that tricky Snell's law. Eta 1 sin I equal to eta 2 sin R, and you can put the values. Eta 1 sin IC equal to eta 2 sin 90, and then it will become eta 1 sin IC equal to eta 2. So sin IC equal to eta 2 by eta 1. So don't go after the symbols. just go after the basics. Next, explain with the help of diagram how the concept of TIR used for transmission of video signal in optical fiber. So here we have optical fiber. It has a central part called core and outer part called cladding. And if we incident a light signal at an angle I greater than critical angle, then it undergoes total internal reflection, and after multiple reflection it is taken out from other end. So here we can say that okay, core has eta lesser, it is denser yeah, it is greater, it is denser medium, and it's rarer medium. So optical fiber has two layers, has a glass fiber called core of high refractive index, and a coating over it called cladding of lower refractive index. Signal in the form of light incident at an angle greater than critical angle. So signal transmits by TIR with 1 to 2% loss only. Trace the rays of light showing the formation of an image due to a point object placed on the axis of a spherical surface separating two. Actually, what they are asking about refractive index eta 1 and eta 2, establish a relation between distances of the object, image, radius of curvature from central point of a spherical surface, hence derive lens maker's formula. So here I would encourage you people to do this question by yourself. I'm just guiding you because it is a lengthy question and direct question, of course. So they are asking about a point object placed on a spherical surface separating two media of refractive index eta 1 and eta 2. So it is something like this, and they are just saying spherical surface, so you can either draw convex surface or concave surface. Here is object, this is eta 1 medium, this is eta, that is arbitrary, that is totally up to us. And here we can mark a point P, it will have some center of curvature C. So this is the ray, normal drawn to it, it will bend toward the normal, and that's all. This is the image, this is L point, perpendicular M, angle of incidence, angle of refraction. This point is close to M as we take paraxial rays which are very close to principal axis. That is why all these angles are very small. At O, alpha angle is there, at I, beta angle is there, and at C, gamma angle is there. And I draw, and most of the student write R in this way, and gamma also look like this. So practice to write gamma in this way. Write C and then this. It is not resembling with R. It is gamma. Okay, so I'm not going to derive it. For this, refer to my video in which I have given its derivation, and using that derive lens maker formula. So how directly this question is asked? So I'm also drawing the diagram for lens maker's formula. Okay, so this is how you need to proceed. This is the first surface P1, so its center is somewhere here C1, and this second surface P2, its center is somewhere here C2, and here we have a point object, so incident ray here, and draw a normal onto it. So it will bend toward the normal, it will reach somewhere here I dash, it has to go there, but it bends. See how accurately I am doing this. Okay, this normal also, because if you would remember that in front of a convex lens, if object is beyond C, image formed between focus and center of curvature. Focus is not defined in this entire derivation so far till now in this construction. So just keep this in your mind. If object is far from C2, then it will be ahead of, I mean between optical center and C1. So just remember this thing. And this is eta 1, this is eta 2, this is again eta 1, and that's all. Calculate the value of angle of incidence when ray of light incident on one face of equilateral prism produces emergent ray which just grazes along the adjacent face, and eta is given root 2. So it grazes out means angle of refraction is 90 degree. So what about angle of incidence on this face? We don't know. So we have to find this R2. Then anything else? Angle of incidence. We have to go on this reverse manner is 60 degree because it is equilateral prism. Okay, so then we will find this R1, and then we will able to find this I. Alright, so first step, because since R is equal to 90 degree, so R2 is equal to IC. R2 will be critical angle then. R2, it looks R like refraction, but no, it is not refraction. It is incident angle for this surface. We mark it as R2. So sine IC is equal to 1 upon eta. That is sine R2 is equal to 1 upon eta means root 2. It implies that R2 is 45 degree. And if R2 is 45 degree, what about R1? We know that R1 plus R2 is equal to A. Remember this thing. This relation comes when we derive this relation I plus E minus A equal to delta. Then comes this, and this should also be considered as a formula. So from here, R1 will be equal to A minus R2, that is 60 minus 45, that is 15 degree. So R1 is 15 degree. Now what about I? Then apply Snell's law. Sine I upon sine R1 equal to eta. Sine I we have to find, and here sine R1 into eta. Sine R1. So if it is given in the exam, then only we can further solve it. Otherwise we have to leave the answer as it is. But they have asked for angle of incidence, so the method is write sine inverse and entire this term. That's all. Alright, so plot a graph to show variation of angle of deviation as function of angle of incidence. Okay, so this, memorize this. From competitive to board, this question is most wanted. This is delta m, angle of minimum deviation, and this I equal to E. So what else they have asked? Establish relation between delta and I, also find relation between angle of prism, refractive index. So they are asking to derive this relation, delta equal to I plus E minus A, and this relation, the angle of prism, sine A plus delta m by 2 upon sine A by 2 equal to refractive index. So once again, I would advise you people go through my videos in which this prism is explained in detail. Okay, what is dispersion of light? How does it depend upon wavelength of light? So the answer is dispersion. Splitting of white light into its components, that is 7 colors, is called dispersion of light. It occurs, actually it is not asked, but still I am telling you, it occurs because different colors has light of different color. Different colors has different speed in a medium. In vacuum all of them move with same speed, but uh, in a medium different wavelength move with different speed. So how does it depend upon wavelength? So we know that delta equal to angle of deviation. Angle of deviation of prism is equal to eta minus 1 into a, and eta is inversely proportional to lambda in medium. So delta depends upon wavelength. So rest of the answer I'm writing here in such a way. So if lambda increases, eta decreases, and hence delta decreases. A small bulb is placed at the bottom of a tank containing water, depth 80 centimeter. Find out area of surface. Okay, the tricky part, tricky question it is. I am drawing a 3D diagram for it. This is the water tank, this is the point, and emerged light is coming out from this area of radius r. It is at a depth h. This is the angle I. Why it is I? IC in fact. It is the angle of a critical angle of incidence. This is also IC. Why? Because beyond this, ray will total internally reflect back, and here it will spread out. So the light within the range 0 to IC, light with angular range zero to IC will emerge out. Will emerged out. Okay. So one more thing we can do. We can use this. Okay. Sine IC is equal to 1 upon eta, that is 1 upon 4 by 3, that is 3 by 4. And now we have to draw a triangle according to this class 10th mathematics. So it is perpendicular upon hypotenuse, perpendicular upon hypotenuse. So this base will be equal to root of 4 4 is 16 minus 9, that is root 7. Okay, so now in order to find this r, what can we do? We can use tan IC is equal to r by h. Tan IC, tan. So r we need r, so r equal to h tan IC. H is r equal to h is 80 centimeter. I am just keeping it as 80. I'm not converting it into meter. Tan IC. So tan IC from this diagram, this is IC. Tan perpendicular upon base 3 by root 7. Okay, can we solve this? It is going to be very difficult one. No, I'm not solving it because they have asked for area. So now we can calculate area. See, because of this root, if I have to find area, pi r square will be the formula, and now I will get rid of this root. pi 3.14 or 22 by 7. No, it will not give us anything. So it is, I think we have to convert it into meter. That will be beneficial. So 0.80, I'm not writing 0. So 3 by root 7. And 8 3 is 24. 2.4 upon root 7. So this is what we can do. I hope you people are getting it properly. So now it is 2.4 into 2.4 because pi r square is there. 2.4 into 2.4 and root 7 square means just 7. And now once again my tricky calculation. So approximate answer, get ready for approximate answer. See, I am reducing it to 3 and I am making them 2.5 2.5. 25 square is 625, so they will become 6.25. So it is 3 into 6.25 upon 7, and 7 9s are 63. So approximately it is 8 might be, because not exact 9 but somewhat less. So now 88 3s are 264 and 2 decimal places. So approximate answer is 2.6, I guess, meter square. So you are given three lenses L1, L2, L3, each of focal length 20 centimeter. An object is kept at 40 centimeter of L1 as shown. Final real image is formed at the focus of L3 here. Find separation between L1, L2 and L3. So this should be done in parts. So for L1, U equal to minus 40 centimeter, F1 is 20 centimeter, and value of V, we know 1 upon F equal to 1 upon V minus 1 upon U. So 1 upon V is equal to 1 upon F plus 1 upon U. 1 upon V is equal to 1 upon 20 plus minus, so ultimately it will become minus 1 upon 40. So this is 40, 2 minus 1, that is 1 by 40. So V equal to 40 centimeter. 40 centimeter on this side. So now for this lens L3, for L3, U we don't know, V we know, 20 centimeter, F3 again 20. So 1 upon F equal to 1 upon V minus 1 upon U. So we'll set this formula for 1 upon U. So it will be 1 upon V minus 1 upon F. So 1 upon U is equal to 1 upon V, that is 1 upon 20, minus 1 upon F, 1 upon 20, that is 0. It means U is at infinity. That's surprising. By the way, it is U3. Everything is 3. And here everything is 1. Alright, so okay, so that's pretty amazing that U3 is equal to infinite. This is possible. U3 is at infinity. It is possible if so this is the first step, this is the second step, so we have to proceed from here. It is possible if image produced by L1 formed at the focus of L2. Okay, so rest of this discussion I will do here. In exam, you can do it on little bit downside, but I am doing it here. So in fact, I will do as if I am doing it in the exam. So I'm not marking anything else. I'm proceeding it. So for L1, image formed 40 centimeter on right side. For L1, this image for L2, sorry, for L2 this image is at its focus, that is 20 centimeter on left. So both lenses are 60 centimeter apart. See, its image is formed somewhere here at 40, and it because it is producing final image at infinity, it means this image formed by this is at 40 centimeter, and that's too the focal at the focus of this L1 L2, and focal length of this is 20, so 40 plus 20, that is 60. And what about the, so L1 L2 equal to 60 centimeter. Now what about L2 L3? Now since image formed by L2 is at infinity, so separation between L2 L3 can have any non-zero value, because for this situation 0 can't exist, so that is why, because it is producing image at infinity like this, so anywhere you can place this another lens. Okay, some common questions on lenses. Image obtained with the convex lens is erect, and its length is 4 times erect image, means it is virtual, and for virtual m is positive, so m is 4 times the length of object, so m is plus 4. If focal length of lens is 20 centimeter, calculate object and image distances. So we know that m is equal to minus v upon u, that is equal to plus 4, so v equal to minus 4u. And now oh sorry, this is lens, so yeah, okay, just keep this thing in your mind, it is lens. And see, for this session 2021, mirror is removed from the syllabus, so that is why just if you want to write to make this that mistake, even you don't have right to do that mistake, you have to follow only lens formula. So 1 upon f equal to 1 upon v minus 1 upon u. So 1 upon 20 equal to 1 upon 4u minus 1 upon u. 1 upon 20 equal to 4u, 1 minus 4, that is minus 3 by 4u. So 4u equal to 23 is a minus 60, so u equal to minus 15 centimeter. And if u is known, v you can find. I'm not doing it. A convex lens is used to obtain a magnified image of an object on screen. So if on screen we can find, then it must be real image, so m will be negative. So here m equal to minus, oh my god, this 10 meter from the lens. All right, if magnification is 19. All right, so m equal to minus 19, and m is once again v by u is equal to minus 19, so v equal to minus 19 u. And what else? Convex lens is used to obtain image of an object on screen 10 meter from the lens. So this is the distance of image, so we can directly put it here, minus, well they have given it 10. If it is real image, then it will be on other side. See, real image object is somewhere here, so real image will be formed on other side, so that will be positive, so v equal to plus 10 meter. From this we can obtain u, so 10 equal to minus 19 u, so u equal to minus 10 by 19. Now we can put the value 1 upon f equal to 1 upon v minus 1 upon u. 1 upon f equal to 1 upon v is 1 upon 10 minus, and again minus, So 1 upon u, 19 by 10. So it is 20 by 10, that is 2, but f equal to 1 upon 2 meter. That's all, or 0.5, whatever you like. Now, radii of curvature of faces of double convex lens, this and this. So for convex, r1 equal to plus 10 and r2 is equal to minus 15. Remember, for convex, r1 is positive, r2 is negative. Focal length of lens is 12 centimeter. Find refractive index. So lens maker formula is there. So I hope now you can proceed further. Okay, some student might have some calculation difficulties. So 13 and 15 LCM is 30, 10 3 is a 10 3 is a 30, so 3 will come here, plus 15 2 is a 5 by 30. So eta minus 1 will be equal to 6 by 12. So that is n minus 1 equal to 1 by 2. So n equal to 1 plus 1 by 2, that is 1.5. So that's all in this video. Now a few more questions on compound microscope and telescope. So I will cover them in another video.